Right, so this is 4.4 part 2. We're continuing to use our trig functions and theta. So in this section, we're going to focus on the sign of our trig functions. So the signs of trig functions in 4 quadrants can be determined easily from the definitions of the functions. We have this chart here, which tells us in quadrant 1, sine, cosine, and tangent is positive. In quadrant 2, sine is positive, the other 2 are negative. Quadrant 3, tan is positive, the other 2 are negative. And in quadrant 4, cosine is positive, and the other 2 are negative. So an easy way to remember this, which it says it on the next slide as well, this is our first quadrant, so all of them are positive. Second quadrant, just sine. Third quadrant, tangent. And fourth quadrant is cosine. So starting with the first quadrant, and a way to remember it is just all students take calculus. So that just tells you which one is positive in each of the quadrants. So again, it says it here, starting with the first quadrant, all students take calculus. So A, S, T, C. And that tells you which one is positive in each quadrant. Remember, if sine is positive, its reciprocal, cosecant, is going to be positive as well. So this just tells us about the 3 basic ones, but we know that the reciprocals go along with them. So this brings us to our first example. Name the quadrant in which theta lies if cotangent of theta is greater than 0 and sine of theta is less than 0. So first thing we need to do is draw. We know that in the first quadrant, all of them. Then we have all students take calculus. So this tells us cotangent is greater than 0. So which 2 quadrants is cotangent going to be positive in? So in this one, all of them are positive. This one, just sine is positive. This one, tangent.
1 and 4.
This one, cosine.
A and C.
Cotangent goes with what? It's the reciprocal of which one?
Oh yeah, tangent.
Tangent.
The 1 and
So we're looking at A and T. So we can cross out S and C because it's not going to be in one of those quadrants, because tangent is negative in quadrant 2 and in quadrant 4. So it's either going to be 1 or 3. Our second thing tells us that sine is less than 0. So is it saying that sine is positive or negative? Negative. So which one of these 2 is sine negative? Our third quadrant, where tangent is. Because it's not going to be in all, because then sine would be positive, because all of them are positive. So the only one left would be quadrant 3. Yes. It's always going to give you 2 rules to follow. The first one is always going to knock out 2 of them. The second rule is always going to knock out the third, so then you'll only have 1 left.
But why would it be in quadrant 4?
Because in quadrant 4, only cosine is positive. And so that would mean tangent is negative there. But tangent has to be greater than 0.
Oh, okay. And then, okay. Thank you.
So just remember, our little helper here, all students take calculus, is talking about the 3 main trig functions. but the reciprocals go along with each one. So when we're looking at cotangent, in our little chart here, we're thinking tangent. The next example is the same thing as the first, so I'm just going to change this to cosine. So for the second page, it's the same page as the first, but just change cotangent to cosine of theta. So here, we have all students take calculus. If cosine of theta is greater than 0, which two quadrants does that knock out right off the bat? Sine and tangent. So now we're just left with quadrant 1 and quadrant 4. So if sine is less than 0, which one does that knock out? All. Because sine is negative. So then we're only left with quadrant 4. Any questions? All right, in our next example, we're given that cotangent of theta is -4/3 and sine is greater than 0. So we have to find sine, cosine, secant, and cosecant. So here we have all students take calculus. If cotangent is negative, what two quadrants does that cancel out?
A and T.
Remember, cotangent goes with tangent. So that crosses out A and what else? T. Oh yeah, you're right. A and T. Sine is positive, so which one does that cross out? Cosine. So our theta is going to be over here where our sine is. So it'll be somewhere over here. So cotangent is -4/3. In terms of SOHCAHTOA, what is cotangent? Adjacent over opposite.
Adjacent over opposite.
Right, so -4 is our adjacent and 3 is our opposite. So I'm going to make a little triangle here. -4 is our adjacent. So if this is our theta, down here is -4. And opposite is 3. How do we find our hypotenuse?
The Pythagorean theorem.
Pythagorean theorem.
You can just do the triple, right? 3, 4, 5.
Yeah. We would do Pythagorean theorem and we would get our hypotenuse as 5, but we also know that if we have 3 and 4 as our legs, our hypotenuse is 5 because it's a 3, 4, 5 triangle. Good job. All right, now how can we find sine?
Opposite over hypotenuse.
Opposite over hypotenuse. So we have 3/5. In the second quadrant, is sine positive or negative?
It's positive.
It's positive, so we just leave it as 3/5. Next for cosine. Cosine is adjacent over hypotenuse. So what's our adjacent? -4. What's our hypotenuse? 5. In the second quadrant, cosine is negative, so we're good, -4/5. Next, we have secant. Secant is hypotenuse over adjacent. So what's our hypotenuse? 5. And what's our adjacent? -4. And again, secant is negative in the second quadrant. So we're good with our negative. And then the last one, cosecant, is the reciprocal of sine. So we have hypotenuse over opposite. What's our hypotenuse? 5, and our
5,
opposite?
3.
3. And cosecant is positive, just like sine. Any questions? All right. Next we have our reference angles. So the value of the trig functions of angles greater than 90 or less than 0 degrees can be determined from their values at corresponding acute angles called reference angles. So reference angles are always acute and positive. On the next slide, it shows some examples of reference angles. So if our theta was this angle here, our reference angle is the acute positive angle. So it goes from our terminal side of our angle to the horizontal line. And our reference angle, we call it theta with the little prime signal. So it's just theta prime, I guess. So this is our reference angle. In quadrant 3, our reference angle again goes from the horizontal line to the terminal angle. So this is our reference angle. And then in quadrant 4, we go from our terminal side to our horizontal line. So this is our reference angle. So if we notice here, using our reference angle, we can always make a triangle here, and we can do Pythagorean theorem, find all 6 trig functions. Same here, make a right triangle, make a right triangle. So that's why we use the reference angle, because using theta here, it's harder to see our right triangle. So we use the reference angle so we can make a right triangle, find our trig functions. To find the reference angle, in quadrant 1, our reference angle is always the same thing as theta. In quadrant 2, we find our reference angle by doing 180 minus our original theta. In quadrant 3, we find our reference angle doing theta minus 180. And in quadrant 4, we find our reference angle doing 360 minus theta. So this chart here that I just drew is pretty much a summary of everything that's given here. But in my opinion, it kind of just helps to have them all in one place. And if you want to, you can even throw in your students take calculus. So this is 4.4 part 2 101. So this is all the basics that you need to know for this section. So this is super important. This box to help you solve them. So first thing you need to do is find what quadrant it's in, then you just plug it in. So depending on which quadrant it's in, you have 4 different formulas to use. So you got to figure out what quadrant it's in, plug it into the formula. All right, our next example says we need to find the reference angle for each value of theta. So first thing we need to do is figure out what quadrant this is in, and then we can find our reference angle. So 300 degrees, what quadrant is it in? This is 90. This is 180. This is 270. And this is 360. Which?
So it's in quadrant 4.
It's in quadrant 4. So in quadrant 4, to find theta, we do 360. To find a reference angle, we do 360 minus the original theta. So what's our reference angle? 60. Any questions on that one? All right, for B, is this in radians or degrees?
Radians.
Radians, because it doesn't have that little degrees symbol, so it's in radians. Even though it doesn't have a pi with it, the pi is just kind of multiplied in there. So first thing we need to do is figure out what quadrant it's in. 90 degrees, or pi over 2 radians, would be in decimal form 3.14 divided by 2. So this would either be pi over 2, which is equivalent to 1.57. Here we have pi, so this is 3.14, or pi. And then this one is 3 pi over 2, which in decimal form would be 3.14 times 3 divided by 2. So this would be 4.71, and this would be 2 pi, so 6.28. All right, so which quadrant would this fall into? 2.3. What is
2.
that? Perfect. 2. It would be somewhere over here. So on the last page, we know something in quadrant 2, we do 180 minus our theta, but this is when we do degrees. So what is the radian equivalent to 180?
Pi.
Pi. So pi minus theta. Pi would be 3.14 minus the original theta, which is 2.3. And that would give us 0.84. So our reference angle is 0.84. Any questions on this one? All right. C. First thing we need to do, find what quadrant it's in. So here we have negative 135 degrees, so we're going backwards now. What quadrant would this be in?
Would it be in 2?
So we're going backwards now. So we start here. This would be negative 90. This would be negative 180. This would be negative 270. So what do you think it falls into?
Oh, okay. 3.
3.
Quadrant 3.
Yep. So now to find our reference angle, we have theta minus 180. Our original theta is negative 135. minus 180? First thing we need to do before we plug it in, because if we did negative 135 minus 180, this would give us a negative angle and a negative big angle. But we know that our reference angle always has to be acute and positive. So first thing we should do is find the positive coterminal angle of 135 degrees. So we're looking for this part of it. So how do we find the positive coterminal angle of negative 135? Add 360. Perfect. So we have negative 135 plus 360. What do you guys get? Anybody? 225.
225.
Perfect. So now we know that if it's in the third quadrant, we do 225 minus 180 to find our reference angle. So 225 minus 180 gives us what? $45?
Yep, 45.
So if it gives you a negative angle, you have to find the positive coterminal angle of it. And then you can just use all the tricks we did on the last page. All right, we have two more. So find the reference angle theta and sketch theta and the reference angle in standard position. So first thing we need to do is what? What do we do first?
Find out which quadrant it is in.
Find out which quadrant it's in. So we're dealing with radians now. So up here we have pi over 2. Here we have pi. This is 3 pi over 2. And this is 2 pi. So what quadrant do we think this is in?
In 3.
So excluding the pi, this would be 1/2 and this is 1/2. Just thinking about like the coefficient in front of the pi. Here we have 2/3.
Oh.
So this would be in the
1/2.
second. Yeah.
Yeah.
So just looking at the fraction in front of the pi, we know that 2/3 is somewhere bigger than 1/2 but smaller than 1. All right, next we need to find the reference angle. So in the second quadrant, what's the formula we use?
180 minus 2 pi over 3.
Right, 180 minus theta, which is 2 pi over 3. But 180 is if we deal with degrees, and here we have radians. So what's the radian equivalent to 180?
3.14.
Yeah, or just pi. So we have pi minus our theta, which is 2 pi over 3. And that's going to be equal to our reference angle. So we subtract. What's the first thing we need to do to subtract these?
Find a common denominator.
Find a common denominator. So we can multiply the top and the bottom here by 3. And then we just subtract. So what's 3 pi minus 2 pi? Just pi over 3. So this angle here is our reference angle. And then this big angle here is our original theta, which is 2 pi over 3. So when it says to sketch theta and our reference angle, this would be how we sketch it. Because our reference angle is just talking about the acute part, but theta is talking about from our starting 0 to our terminal side. Ready for the next one? Any questions on this one?
Nope.
All right, let's look at B. What's the first thing we need to do?
We have to find out which quadrant it's in.
Which quadrant it's in. All right, so here we have pi over 2, pi, 3 pi over 2, and 2 pi. So what do we think 23 pi over 6 is going to be in? Is 23 pi over 6 bigger than 2 pi?
Yes.
Yeah, how many times does 6 go into 23?
3 times.
Yeah, almost 4. So what should we do to help us find the coterminal angle to figure out what quadrant this is going to be in? Just to find the
You have to
smaller...
subtract it.
Yeah, we're just finding the smaller version of this angle. So we have 23 pi over 6 minus 2 pi. So if our angle wraps around here, just for an example, now we're subtracting the whole wrapping around part. So we're just looking for this part. So we're trying to see where this is going to fall. So we're subtracting 2 pi. We have to multiply the top and the bottom by 6 so we can subtract. So this is 12 over 6. So 23 pi minus 12 pi would be 11 pi over 6. All right, so where do we think 11 pi over 6 is going to fall?
So like in the fourth quadrant?
In the fourth quadrant. Perfect, because 11 pi over 6 is bigger than 3 pi over 2 and smaller than 2 pi. So we wrapped around one whole time, and then we went all the way around again until the fourth quadrant. So we're over here somewhere. So we're looking for our reference angle, which is this part. So how do we find our reference angle? Perfect. What are we going to use for our theta?
The 11 pi over 6?
We want to use the 11 pi over 6 because if we use the original, we would still be left with something that's bigger than an acute angle. So we use the 11 pi over 6, our coterminal angle. So typically our formula for our reference angle is 360 minus theta, but here we're in radians, so 2 pi minus theta. So our reference angle is going to be what? Awesome, pi over 6. So here we multiply the top and the bottom by 6, so we can subtract. So then 12 pi minus 11 pi is just 1 pi, so pi over 6. Alright, to see how a reference angle is used to evaluate a trig function, consider the point xy on the terminal side of theta as shown in the figure. So this takes us all the way back to the first example we did. We are finding when theta is our reference angle, even though our actual theta is this angle. Using our xy point, so using our adjacent, opposite, and hypotenuse to find our trig functions, when using the reference angle, we would get the same thing as if we used theta, but using the reference angle is easier because we have this little triangle. So we always want to find our reference angle and take our 6 trig functions off of that. This again is just same thing we did in part 1. We have sine is y over r, tangent y over x, and sine opposite over hypotenuse. Same stuff. So here, sine of theta and sine of our reference angle are equal, except the sine sometimes, so the sine meaning whether it's positive or negative. So we would always have to do, all students take calculus to help us figure out the sine. So always when evaluating your trig functions, the last thing you want to do is just double check your sign, make sure your positive and negatives are right. You can do that by all students take calculus. So here, to find the trig function of any angle theta, so when solving for our 6 trig functions, first thing we need to do is determine the function of the associated reference angle. So we need to find our reference angle. And then depending on the quadrant that theta lies, fix the appropriate sign to the function value. So we just have to check the sign. So the last thing you want to do is check the sign. Here is a little chart for convenience, it says. But it just tells you that sine of 0 is 0, sine of 30 is 1/2. So it's just some common ones that we have here. Our 30, 60, 90 triangle, our 45, 45, 90, some common special right triangles.
Alright, so for A, B, and C here, the answer for A is here, but we can just ignore that. So looking at A, we need to find the cosine of 4 pi over 3. Now in finding our trig functions, it's easiest to see it when it's in degrees, because usually it'll be a 30, 60, or 45 angle, and that way we know what our trig functions are for those angles. So we want to convert 4 pi over 3 to degrees. So to convert, we multiply by 180 over pi. So the pi's cancel. We can divide 3 into 180, and this would be 60. And then 60 times 4 would be 240. So this is actually the cosine of 240 degrees. So same thing, no difference there. Now we want to find which coordinate, which quadrant this falls into. So this is 90, this is 180, this is 270, so it's going to be somewhere in here. So to find our reference angle theta in the third quadrant, we take the angle that's given, so 240 minus 180. So this gives us a reference angle of 60. So now we need to find the cosine of 60 degrees. So the cosine of 60, we go back to the page before that had all of our special right triangles on it, so like 30, 60, 45, and cosine of 60 is 1/2. Now we need to figure out if this is negative or positive. So we need our all students take calculus. And we're looking at cosine. So in the third quadrant, only tangent is positive, so cosine is negative. So our answer here is negative 1/2. Next, let's look at B. So we need to find the tan of negative 210. So first thing we want to do is find the coterminal angle. So we need to add 360 to negative 210. So negative 210 plus 360, which would be 150. So next we need to find which quadrant this falls into. So this is 90, this is 180. It's going to be somewhere in between 90 and 180. To find out what our reference angle is in the second quadrant, we do 180 minus 150. So this gives us a reference angle of 30. So now we need to find the tangent of 30. So going back to the page before, the tangent of 30 is square root 3 over 3. And we're in the second quadrant, so all students take calculus. Only sign is positive in the second quadrant, so that means tangent of 30 is negative. So negative square root 3 over 3. All right, and lastly, we need to find cosecant of 11 pi over 4. Pi over 4. So first thing we want to do is convert this to degrees just so we can see it a little bit better. So we have 11 pi over 4 times 180 over pi. The pi's cancel. 4 goes into 180 45 times. So this is 11 times 45, which is 495. So 11 pi over 4 is 495 degrees. So next thing we need to do is find out where this falls on our unit circle. Not our unit circle, but our coordinate plane. So we want to find a coterminal angle of this because we know this is going to wrap around at least once and then go a little bit further. So we want to subtract 360 from this so we can see it a little bit better. So this would be 135 degrees, which would be somewhere in between 90 and 180. So in the second quadrant over here. So in the second quadrant, to find our reference angle, we need to do 180 minus the theta. So this would give us a reference angle of 45 degrees. So we need to find the cosecant of 45 degrees. Going back to the chart before, we look for sine of 45 degrees, and then we know we just take this reciprocal of that. So sine, I'm going to do it on the side over here. Sine of 45 is square root 2 over 2. To find the cosecant, we take the reciprocal, so that would be 2 over square root 2. We have to rationalize this, so we need to multiply the top and the bottom by square root 2. So these cancel, so we get 2 square root 2 over 2, which is just square root 2, because the 2's cancel. So our cosecant of 45 is square root 2 And we are in the second quadrant, so all students take calculus. Sine is positive in the second quadrant, so that means it's reciprocal. Cosecant is also positive, so we have a positive square root 2. So cosecant of 11 pi over 4 is square root 2.